Unit 3.5 Standard Deviation and Coefficient of Variance. So let's continue our discussion further in the concept of measure of dispersion. So guys, in this class we'll discuss about standard deviation and coefficient of variance. So overview. Have you ever wondered how we can quantify the spread or risk in a data like investment decisions or product quality? So in this session we'll explore the concept of standard deviation, which is crucial statistics for understanding your data variability. Here we'll compare standard deviation with other measures like range and variance, and we'll try to discuss its role in decision making. So at the end of this topic, you will be able to define what is standard deviation and its significance in statistics. Here we'll discuss the how we can analyze the mathematical formulation of combined standard deviation and coefficient of variation.
Now, talking about the learning objective from this class, at the end of this topic, you will be able to define standard deviation and its significance in statistics. We are going to analyze the mathematical formulation of combined standard deviation and coefficient of variation. Now, introducing this topic called standard deviation. Standard deviation is defined as the positive square root of the arithmetic mean of the squares of the deviations of the given observation from the arithmetic mean. Okay, so basically, whenever it comes to define or noting standard deviation, we note standard deviation by the Greek letter called sigma. Okay, so whenever we are analyzing the risk on any instrument, we measure the risk of any instrument most probably by using standard deviation, where we assume the condition of normality. Going further in standard deviation, the concept of standard deviation was introduced by Carl Pearson in 1893, and it is the most important measure of dispersion and widely used in many statistical formula. It is also called as root mean square deviation and provides accurate results. Okay, the square of standard deviation is called variance. Okay, so going further, when we discuss standard deviation, if we have to calculate standard deviation of individual series, then we need to take the deviation from the actual mean of the data, and then what are the deviations we got from the uh, actual mean. Now, discussing the calculation standard deviation of individual series, we can either do this calculation by taking deviation from actual mean, where we actually calculate the arithmetic mean by the formula called summation of x by n, and that value, that mean value, we consider for calculating the deviation of all the data from the actual mean, and that way we proceed our calculation. That is the one method. The other method, what we can do, instead of working on actual mean, we can even work on assume mean, and through which also we can calculate the standard deviation. Okay, now discussing a numerical of a scenario when we are considering the calculation of standard deviation from the deviation from actual mean. Okay, where the method adopted when the mean is a whole number. So imagine, consider a case where the arithmetic mean based on calculation, if we get a whole number, based on that a scenario, let's do a numerical. So once we get the actual mean of the series, okay, first we find the actual mean of the series. Then what we do, we find the deviation of each value from the mean. Okay, and then we do the square of that deviation, and then we divide that square of deviation by the number of the observation. Okay, and this square root is the standard deviation. Okay, the formula is you can say the formula is summation of x square by n, or you can say summation of x minus x bar ka whole square by n. Okay, now discussing the formula, like when we are considering the scenario where the deviation is taken from the assumed mean. So here the method is adopted when the arithmetic mean is a fractional value. Since taking the deviation from fractional value are difficult, so they are taken from the assumed mean. Okay, the formula in this scenario would be a square root of summation of d square by capital N, and n is the summation of frequency, minus summation of d by capital N the whole square, where d stand for deviation from the assumed mean. Assume any of the item in the series as an average A. Okay, and then we need to find out the total deviation from the assumed mean, that is x minus A, denoted by D. Okay, D is called step deviation, and the total of that deviation is called sum of D. What we need to do once we got this value, then we need to do the squaring of the deviation and add up the squared value. Okay, and then we need to substitute this value in the given formula. This formula already we have discussed. Okay, and then the simplified formula for the standard deviation in this case can be like in this, where the formula is sigma is equal to 1 by n, then under the square root n into summation of d square minus summation of d ka whole square. For the frequency distribution, in case if the frequency distribution is given, then the formula would be C divided by capital N. Capital N here means the sum of frequency, the square root of capital N, summation of FD square minus summation of FD the whole square. Okay, so if we use the actual mean formula, so the x value is what is given to us, we can find the arithmetic mean of this x value. The total sum of this data is 120 and the total n data is given. So the mean of this data is 15. Okay, then what we need to do, we need to find uh, the individual x value minus the mean value. The mean is 15. So x 14 minus 15, 22 minus 15, 9 minus 15, 15 minus 15, 20 minus 15, 17 minus 15, 12 minus 15, 11 minus 15. So, what are the x value given in the problem? These x value we subtract from 15 because 15 is the actual mean of the data. So, what we do, we apply this formula of deviation from the actual mean, where the actual mean, we first calculated the actual mean of this data, which is 15, and then we subtract each of these values from the 15. Okay, so we got the value as minus 1, 7, minus 6, 0, 5, 2, minus 3, minus 4. And then we did the square of each values, x minus x bar value, the square we did. Okay, and then the total sum of this, what we got is 140. So the formula of standard deviation is square root of summation of x minus x bar ka whole square by n. Okay, where the sum of x minus x bar whole square is 140. So 140 by 8, if you do, we'll get 70 by 4. 70 by 4 means 35 by 2. 35 by 2 means 17.5. So square root of 17.5 would be close to 4. So that is 4.18. Okay, let's do another numerical. Here in the table given below, the marks of 10 students in the subject called statistics is given, and we need to calculate the standard deviation, and the 10 student marks are given to us. What we need to do, based on the marks what is given, okay, we just consider a assumed value of x instead of working on the actual arithmetic mean calculation. We can work on the assumed value that I just took one value of x. Out of these value I just took one value as 57 as an assumed mean. Okay, and then I found the deviation of all these values from 57. 43 minus 57, 48 minus 57, 65 minus 57, 57 minus 57, 31 minus 57, 60 minus 57, 37 minus 57, 48 minus 57, 78 minus 57, 59 minus 57. So I got all the D value, and then the summation of D is done. Summation of D I got as minus 44. Okay, then whatever the D value I got, I did the squaring of the D value. Okay, so I minus 14 square is 196, minus 9 square is 81, 8 square is 64, minus 26 square is 676, 3 square is 9, 20 square is 400. Okay, 21 square is 441, 2 square is 4, and then I did the sum of this. So the sum of D square we got is 1952, and the sum of D we got is minus 44. Okay, So then we apply this formula, square root of sum of d squared by n minus sum of d by n ka whole square. Okay, so here sum of d square we got is 1952 and n is 10, and sum of d we got is minus 44 and n is 10. So if, when we apply this formula, 44 square is 1936 divided by 100. You got 19.36, and 1952 by 10 you will get as 195.2. When we solve this, we get square root of 175.84, which gives you 13.26. So the sigma value we got is 13.26. Okay, now when we are talking about the calculation of standard deviation by actual mean method, here we need to calculate the mean of the series, and then we need to find the deviation of various items from the mean. Okay, and then we need to do the squaring of the deviation and multiply by their respective frequencies to get FD square, and then we need to take the sum of this sum of FD square and apply the formula, which is sigma is equal to square root of summation of FD squared divided by summation of S. Okay, since the calculation of actual mean in fraction is time consuming and labor intensive, so this method is rarely used in practice. Now, when we are working on assume mean method, okay, so in assume mean, what we do out of any values given in the X or Y, we just take one value and call that value as a assumed mean, and then we find the deviation of each value from the assumed mean that we denote by D, and that value what we got D, we multiply with the respective frequencies, and we took the sum of FD. Okay, and then whatever the D value we got, we even do the squaring of those values, and then we multiply those values with the respective frequency to get FD square, and then we took the sum of that value so that we get summation of FD square, and then we substitute them in this formula where sigma is equal to square root of summation of FD square by summation of F minus under the bracket sum of FD by sum of F ka whole square, where D is equal to X minus A. Okay, now here we need to calculate the standard deviation of the following data. Here we have some X values, and frequency is talking about how many times that value is repeated. Okay, so the X values are 20, 22, 25, 31. Okay, uh, and 40, 42, 45, and their X values are given to us. So in this question, we need to calculate the standard deviation for the following data, where the X and F values are given to us. Like X are basically the values, and F is the number of times that value is repeated. So once we start solving this question, we have the X value, we have the F value. We can directly calculate the mean by following the formula called summation of Fx by summation of F. That way, we can get the value of mean. Or what we can do, we can follow step deviation, where out of these X value, we just randomly took one value, call that value as assumed mean, and let that value is 31. So what we did, we found the difference of all these values from 31, 20 minus 31, 22 minus 31, 25 minus 31, 31 minus 31, 35 minus 31, 40 minus 31, 42 minus 31, 45 minus 31. That we did, and that we noted with the small d sign. Okay, once we got this small d, that is called step deviation, we did the square of that. Okay, when we did the square of this, that we get summation. We got d square. Okay, and we can do the sum of that d square. Okay, and then we multiplied the frequency with the d. So we got f into d, and then we did the sum of that value. We called a summation of md. Here the summation of md we are getting is 167. And then the d value, what we got, we did the square of the d, which we called it d square, that we multiplied with f. So we got fd square. Okay, and then we did the sum of that. So we got the sum of fd square as 6037, sum of fd as 167. Okay, and then total sum of frequency or capital N is 107. Everything we put in this formula, this is a formula. Sum of FD square is 6037. Sum of F is 107. Sum of FD is 167. Sum of F is 107. We applied the formula and we got the standard deviation value of 7.35. Okay, now if when we are working on a step deviation method, so we just took the any value from the x, called that as assumed mean, or we took the central value called it as assumed mean, and then if we are observing that whatever the d value we got, if all these d values are dividing by some common term, so that we called as C, or C is normally the class width of the interval. If the class intervals are in the difference of 10 10 10, definitely all the value will be divided by 10. So the C is the class width. And then what we do, we need to multiply the d value what we got with the frequency, and then we did the sum of that frequency into d, which we call a summation of fd, and then we did the square of the deviation to get d square, and then we multiplied that square deviation by the respective frequency, and we did the total as summation of fd square, and then everything we substitute in this formula, okay, where the formula is square root of summation of fd square by n minus summation of fd by n ka whole square into C to get the standard deviation. Okay. So imagine this is the data given to us, and we want to find the standard deviation for from the following data, where the marks of the students are given, and some certain marks are given, and which student, how many student got that mark, that is the frequency is given to us. Okay, and now if you want to solve this question, so here what we did, we just took one value called that assumed value, and that assumed value is let is 30. So when I subtracted all the value from 30, 10 minus 30, I get minus 20, 20 minus 30, I got minus 10, 30 minus 30, 0, 40 minus 30, 10, 50 minus 30, 20, 60 minus 30, 30. Now all these values what we got, minus 20, minus 10, 0, 10, 20, 30, we realize all these values are divided by 10. So when let it divided by 10. So we got the values minus 2, minus 1, 0, 1, 2, 3. Okay, so the C here is 10. Then we did the square of that D value, and then we multiplied that with frequency. We multiplied the D value with the frequency. We took the sum of all these values. So the sum of FD square we got is 109. Sum of FD is 5. The sum of F is 60. C is the 10. So then we applied them in the formula, sum of FD square 109. Sum of F is 60, sum of FD is 5. Okay. And C here is 10, not 100. Correct here. C is here 10, not 100. Okay. Then when you solve this, okay, we got the standard deviation value as 13.45. Okay, so when it comes to combined standard deviation, so imagine that there's a series of n1 items having the mean x1 bar and the standard deviation sigma 1, and there's another series having n2 items having the mean called x2 bar and the standard deviation sigma 2. Then their combined mean and combined standard deviation would be square root of n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square by n1 plus n2. Okay, like here, this is the question. Like here, the data is given about villages. The number is given. Their average income is given. And their standard deviation is given. Okay, so we need to find the combined standard deviation for this data. Okay, these are the data given to us: n1, n2, and x1, x2, okay, x1 bar. These are mean of this, mean of first data, mean of second data, standard deviation of first data, standard deviation of second data. So we can find their combined mean, okay, by this formula. So that is n1 x1 bar plus n2 x2 bar divided by n1 plus x n2. 175, 186 is the individual mean of the n1 and n2 data. So when we apply this formula, N1 is 600, X1 bar is 175, N2 is 500, X2 bar is 186. So when you applied the formula, we got the combined mean as 180. So once we got the combined mean as 180, then we can find here D1 and D2. D1 and D2 is the deviation of these values from their combined mean value. Okay, so D1 is basically the mean of the first data minus the combined mean. 175 minus 180. This is minus 5. And D2 is the mean of second data minus combined mean, which we got as 6. And then we applied the formula here. N1 is 600 into sigma 1 is square. Sigma 1 given as 10. So sigma 1 is square would be 100. N2 is 500, sigma 2 given is 9, so the square of that would be 81. Okay, n1 is 600, d1 we got minus 5, its square would be 25. N2 is 500, d2 we got as 6, its square would be 36. Divide by n1 plus n2. So when we solve this, we'll get the combined mean as 11.0. Now, merits and demerits of standard deviation. Standard deviation is regionally defined. It defines definite and based on all the observation where we use actual sign. It is based on and has all the merits of arithmetic mean. Standard deviation is widely used in the measure of dispersion, and it is used even in further algebraic treatment. Whatever when we talk about when we talk about further statistical calculation like statistical quality control, okay, or we talked about Six Sigma calculation, anything, and in further calculations of statistics, when it comes to discuss about risk and return, even in portfolio management, we use standard deviation. It's very widely used measurement of risk in the data. Okay, and it is less affected by the fluctuation of sampling and hence it is stable. It is basis for measuring the coefficient of correlation and sampling. Demerits that it is not easy to understand and difficult to calculate. It gives more weight to the extreme values because the values are squared up and it cannot be used for comparison as it is absolute a measure of variability. Now discussing about coefficient of variation. Coefficient of variation is obtained by dividing the standard deviation by the mean and multiplying it by 100. So similarly, coefficient of variation formula is sigma by mean into 100. Okay, let's discuss a numerical. Like in the fact, there are two factories are there, A and B, which are located in the same industrial area. The average weekly wage in rupee and the standard deviation of the two factories are given to us. For the two factories, the average is given to us, the standard deviation is given to us, and the number of workers are given to us. Question comes: which factory A or B pays the larger amount of weekly wage? And which factory A or B has the greater variability in the individual wages? We calculate the total wage paid by factory A. So for that, we multiplied the arithmetic mean of the fact given by the factory into the number of the data given by factory A. So here, as if you see in the question, the average of factory A is given as 34.5 and the number is given as 476. So when we multiply the average with the number of worker, we can get the total weekly wage of factory A. Similarly, when we multiply 28.5 with 524, we can get the total weekly wage for factory B. Okay. So here in the calculation, what we did, we calculate the total wage paid by factory A, and similarly by multiplying the average with the number of worker, we can get the total wage paid by factory B. So the total wage paid by factory A is 16,422, while the total wage paid by factory B would be 14,934. And therefore, the factory A pays out the larger amount as weekly wage. And then we can calculate which factory A or B has the greater variability in individual wage. So for that, we use coefficient of variation. Okay, and coefficient of variation formula is standard deviation by mean into 100. The standard deviation we got from the problem as 5 and the mean we got as 34.5. Okay, so when we use coefficient of variation, we can say that for factory A it is 14.49, and while for factory B it is 15.79. So since the factory B has the greater variability in the total wage, since the coefficient of B is greater than the coefficient of A. So since the coefficient of variation of factory B is greater than the coefficient of variation of factory A, so we can say that the factory B has the greater variability in the individual wage as compared to factory A.
Let's summarize the concept what we have discussed so far in this session. Standard deviation is a quantitative statistical measure that quantifies the amount of variation or dispersion in the set of data values. When we talk of standard deviation, it reflects how much the individual data points it deviates from the mean or the average from your data set. Okay, when we are talking about standard deviation, a low standard deviation indicates that your data points are clustered close to your mean, suggesting consistency, while high standard deviation shows a greater variability with the data points spread out even with a wider range. When we talk about standard deviation, it is calculated as the square root of the variance. When we talk about standard deviation, it is widely used in fields like finance, in research, in quality control, even to assess risk, variability, and in reliability in data. So I hope you have understood the concept of standard deviation and coefficient of variance what we have discussed in this class. So it's time to wind up this session. Happy learning.